The first one, okay? The second one, they don't give it too many examples, maybe like one or two overall, but more of our problems with the limits of trigonometric functions will be related to the first one. Okay, so let me give you the example, and we'll continue. So this will be 4? I think so, right? So let's say we're looking for a limit of sine of 7x over x when x is approaching to 0. So we're looking for this limit. Now one thing before I forget, Weber sine has little problem with the way we put trig. So for example, if you put sine of x, it takes it. Also, if you put this as sine of x with the parentheses, it takes it. But if you put sine of 3x, it's going to say that you are wrong. So Weber sine would like you to put what?
Parentheses.
The parentheses, okay? So if it's x, it's fine, don't put parentheses, okay? But if it's sine of 2x or something more complicated inside, then better to put the parentheses. But please don't put them everywhere because you're afraid. Because then it will be difficult to see exactly what's happening. So better just to know where to put them. So keep this in mind. So the first step with the limit, what do we do?
Inputs.
Substitute, right? So if you substitute, we get sine of 0, right? And what is sine of 0?
1.
You need calculate for that?
0.
0. And overall, 0. Okay? But also, the way I said this to you, I said not just really 0, 0 right away. I said sine of what? 0 over 0. It's important to recognize this, okay? You have sine of 0 over 0. Now, we know it's 0 over 0. We know. But for these type of problems, you have to see this. Sine, if you go back, for example, sine of 0 over what? 0. That's important for us to see this, okay? Also, if you look at the rule over here, for example, this one, pay attention. It says sine of x over what?
X.
X, right? If you go back to this problem, it says sine of 7x over what? X. So if I'd like to use this formula, let's say, I must have 7x over here. You understand that? These two must be what? The same. These two must be the same. But again, only if you get sine of 0 over what?
0.
Over 0. That's important, okay? So now you have to use kind of simple algebra here to fix this. So if I have a sine of 7x, right? And I have x, but I want to put 7 on the bottom, you cannot just put 7 on the bottom, right? You have to make it right. So you have to put what? 7 here and 7 right here. Yes, no?
Yeah.
Okay, to fix this. And now, you really, I should say don't pay attention to 7, you have to. But normally we'll think about this. So this 7 will be moved outside of the limit because it's just a constant. But what we're looking at sine of 7x over 7x when x is approaching to 0. So now, this piece right here will approach to what?
1. 0. 0.
Pay attention to the first one.
Oh, 1.
1. It goes to 1, okay? So I have 7 times 1 equals 7. So again, when we have sine of 0 over 0 and the same, you see x and x, or 7x and 7x, and you get sine of 0 over 0, then no matter what you have inside, like 7x, 25x, or 1/3 x, you understand that? It will be what? It will be 1. So 7 times 1 equals 7. Okay, so we're trying to fix that. So let's do one more. So let's say I have limit sine of 3x times by sine of 5x over x squared when x is approaching to 0. So again, if we substitute, direct substitution, we get 0 over 0, right? But do you see sine of 0?
Sine squared of 0, right?
So we have sine of 0, right, when you put 0.
Yeah.
And also you have what? Sine of 0. And you have 0 on the bottom, right? So this is what we have. So it kind of fits, but not exactly. Because if you look, what do you see here? Sine of what? 3x, right? What do you see here? Sine of 5x, right? What you want to see? You want to see x. So can we split x squared?
Yeah. You could do
So if I change this to this, sine of 3x over x times by sine of 5x over x, it's the same, yes?
Yeah.
But now it's kind of better to look at this because it's really more related to what, well, to the problem or formula that I gave you. But it still doesn't work because it's what? 3x, right?
Yeah.
I'm going to put one extra line just for your notes, but you can skip this. So to fix this, so I have sine of 3x over 3x, but I have to fix, right? I have to put that 3. Then I have times, and I have sine of 5x over x, but I want to see 5, so 5 and 5. Fixing this, right? And again, with the process that we had before, and using properties, you can move this 3 outside, and what's left, limit of sine of 3x over 3x, x approaching to 0. And again, I can use the second limit, okay? Second time. It's according to the property that we had before in section 2.3. So I can have, first of all, 5 in front, this 5 right here, and that 3, okay? This is what we have. And then we have sine of 5x over 5x. So, 3 times. What do we know about this? It goes to what?
1.
It goes to 1, and again, sine of 0 over 0, okay, it goes to 1 times 5, and this one also goes to what?
1.
1. So we get 15, and that's the answer. Okay? So now I'm going to show you one more. This will be the last one, and then tomorrow maybe I'll give you one more. We're related to this. But let me show you the last one, because I feel like if you will start the homework assignment, let's say you should have this problem. So 6, we have limit, and let's say I have sine of x minus 2 over x squared minus 4, x is approaching to 2. So if I substitute, I get sine of 0, yes, no?
Yeah. Yeah.
Okay, I get sine of 0. Well, I'm just putting 0, okay, because we know sine of 0 is 0. And over what?
0.
0. So we still have 0 over 0. But look carefully right now how this problem is different from the previous one. It says x approaching to what?
2.
X approaching to 2. Not 0. But you still have the same concept. Do you understand that? Because what do you have? You have sine of what? 0 over what? 0. Do you see that? And how do we finish this? Well, factor the bottom piece. So we get x minus 2 and x plus 2. And we get sine of x minus 2. So how can you regroup this? How can you split this now that we can use our concept?
Could you multiply the top by x plus 2?
No, you actually don't have to, because look, let me split this for you. Do you see this?
Oh, okay.
So look at that first one. It says sine of x minus 2 over x minus 2, right? But it says x is approaching to 2. So if I do the last line, okay, let me put this one that you can see the steps. So I have this one, we'll still keep this, and I'll put limit for this one. So what do you think this is?
1.
It's 1, right? It's 1. So it doesn't say x approaching to 0. But if you look carefully, you have that sign of 0 because you put 2 inside. And again, you put 2 inside, you get 0. And these two are exactly the same. Can you see that? So it's still 1. It's still 1. So this was 1, and then you substitute here, x equals 2, right? What do you get? 1 over
4.
And we're done. Okay? So these limits will require this kind of little manipulation here, and like previous ones. But also, there's some limits that you just go through the process of simplifying. You don't have to involve, again, where I have it, for some limits you don't have to involve any of these. Okay, just kind of go through simplifying. But most of them you will see with this concept, sine of x over x. Okay, and this one you can hardly see, but I put it just to make sure you see it. So that's what we have. Do you have any questions? No? So memorize the formulas, refresh the identities, unit circle, and just keep going and try to simplify as far as you can. Again, you can look at all of your answers and you can see that some of them are way too long. And I'm not getting your points. Okay, that's good. That's great. You get your points. That means you taking the derivative right. But sometimes you do not simplify the function or derivative to the very end. So always try to do this. Always try to simplify. And like I said before, it depends how far you can go. But don't just take the derivative and stop. And put it in and it's going to say you're right. It doesn't mean you're right 100%. You're right only to the point when you took the derivative. But after that, we have to simplify. So, last time, any questions? No questions? All right. Well, then keep working on your assignment. I'm going to put the new vocab for section 3.4. And we'll get the chain rule. So basically you will see kind of the formula overall that we're going to use. And with the chain rule, basically you will have a possibility to take the derivative almost of any function, speaking like algebraic functions. So chain rule will help us to deal with more complex functions. Alright, so thank you guys. I'll see you tomorrow.
Thank you.